Right now, you are spinning at 1,670 kilometers per hour. You feel nothing. No wind, no push, nothing that gives it away. That number is Earth's rotation speed at the equator. So, why is this planet spinning at all? The story starts 4.6 billion years ago, before Earth existed. Back then, there was only a cloud, gas and dust, spread across trillions of kilometers of space. Astronomers call it the solar nebula. This cloud already had a tiny rotation. It came from turbulence inside the Milky Way itself, barely noticeable at first. Almost. Still. Then, gravity started pulling the cloud inward, and that changed everything. Physicists call it conservation of angular momentum. Picture a figure skater pulling her arms in. She spins faster, without adding any extra force. The collapsing cloud did the same thing. As it shrank, its spin sped up dramatically. Within about 100,000 years, the cloud flattened out. It became a spinning disk, wide and thin. Scientists call this a protoplanetary disk. At the center, gravity crushed material into the sun. The sun inherited that same spin direction. Astronomer Immanuel Kant proposed this idea first, in 1755. Pierre-Simon Laplace refined it decades later, in 1796. Together, their nebular hypothesis still holds up today. Out in the disk, dust grains started colliding. Static electricity stuck tiny particles together first. Over millions of years, those clumps grew into rocks. The rocks grew into planetesimals, some the size of mountains. Every one of them still carried the disk's original spin. Gravity pulled these bodies together in violent collisions, one collision after another, over about 10 million years. This is how Earth was built. Piece by piece, each impact nudged the planet's spin in a slightly different direction, but most impacts came from the same swirling disk, so the net spin lined up counterclockwise, seen from the North Pole. Then, around 4.5 billion years ago, something massive hit Earth. Scientists call the impacting body Theia, roughly the size of Mars. The collision was so violent it melted the outer layers of both worlds. Debris from that crash flew into orbit around Earth. Over time, that debris clumped together and formed the moon. The impact also sped up Earth's rotation and tilted its axis. That tilt sits at 23.5 degrees, and it gives us seasons. Right after the impact, a day on Earth lasted about 6 hours. 6 hours from sunrise to sunrise, not 24. The new moon did not just sit there quietly. Its gravity pulled on Earth's oceans, creating tides. Those tides dragged against the spinning planet like brakes. Slowly, over billions of years, Earth's spin lost energy. That energy did not vanish. The moon absorbed it. The moon drifts about 3.8 centimeters farther from Earth every year. Geologist John Wells found proof of this in 1963. He studied fossilized coral, which grows daily, and yearly rings. Coral from 400 million years ago showed about 400 rings per year. That means Earth spun 400 times, not 365, in one orbit. Days back then lasted around 22 hours, not 24. So the day has been stretching slowly the entire time. But here is the real question. Why does it keep going? On Earth, spin a top on a table and friction stops it. Space has no table and no air to push against. There is almost nothing out there to slow a spinning planet down. This is Newton's first law of motion from 1687. An object in motion stays in motion unless something stops it. Earth has been spinning since it formed, with almost nothing in the way. The moon slows it down, but only by 1.7 milliseconds per century. At that rate, it would take billions of years to matter much. So the spin under your feet right now is 4.6 billion years old. It started in a collapsing cloud of gas and dust. It sped up when that cloud flattened into a disk. It got knocked sideways by a planet-sized impact, and it kept going because space gave it nothing to push against. You are not standing still. You never have been. 1,670 kilometers per hour, carried by a cloud that collapsed before the sun existed.